Find the domain of f of x equals the quantity x plus 3 all over the quantity x squared minus 25. This is a rational function, so for the domain we need to figure out all values that make the denominator equal 0 and remove those values. So I'm going to go ahead and set x squared minus 25 equal to 0. I can either factor it and set each factor equal to 0, or on this example I can add the 25 to the other side and solve for x by taking plus or minus the square root of 25, which is 5. So we get two answers, plus or minus 5, as the values that make the denominator equal 0. So the domain is everything except these two answers. So we wanted to know what are the values that make these equal 0 and remove those. In interval notation, that's going to be x values from negative infinity to negative 5, open parentheses around negative 5, union, open parentheses around negative 5 to 5, open parentheses, union, open parentheses 5 to infinity. So this says everything except negative 5 and except for 5 because there are open parentheses. Now let's find the domain of f of x equals the square root of the quantity 2x minus 3. On an even root function, we can't have any negatives underneath that even root. So in order to find the domain, we need to solve when is 2x minus 3, the part underneath the square root, when is that greater than or equal to 0? So it just can't be negative. It can be greater than 0 or equal to 0 underneath the square root. So we're solving a linear inequality here. I'm going to add the 3 to the other side and then divide by 2. So x values greater than or equal to 3/2 are going to make the part underneath the radical greater than or equal to 0. So that is my domain. In interval notation, that would be brackets around 3/2 since we're including 3/2, and everything bigger than that going all the way to infinity. Now let's find the domain of f of x equals x to the 5/2 plus x to the 3/2. Well, here what I'm going to start by doing is turning these back into roots. So here x to the 5/2 would be the square root of x to the 5th. So the denominator of the rational exponent becomes the root. So here a square root, and same thing here, this is also a square root. So this would be plus the square root of x cubed. And what we can also do is we can also think about this exponent of 5 as on the outside of the root. So this is the square root of x all raised to the 5th, and this is the square root of x all raised to the 3rd power. And writing it like this helps us recognize that what we're really dealing with here are two even root functions. They're two square roots. So we're still limited when I have an even root to having the part underneath be greater than or equal to 0. And in that case, it's just x. Where is x greater than or equal to 0? So in interval notation, that's going to be x values from bracket 0 to infinity. Now let's find the domain of f of x equals x to the 2/3 plus natural log of the quantity 2 minus x divided by 4. We're going to have to think about the domain of each part of this sum individually and then where they intersect. We'll start with x to the 2/3. We can think about this as the cube root of x squared, and we could break it down even farther. We could think about this as the cube root of x all as a quantity squared. So basically here, since this is an odd root, that means x can be any number, positive, negative, or 0. So the domain of this odd root function is all real numbers. So we'll go ahead and write that, x values in negative infinity to infinity, and hold on to that because now we need to find the domain of the second part, the natural log of the quantity 2 minus x over 4. Well, the inside of a logarithm, regardless of the base of the log, is that the inside, the argument, has to be positive. It can't equal 0 and it can't be negative. So we're going to have to solve a little inequality here to determine the domain of the second piece. We're going to solve when is 2 minus x over 4 greater than 0, positive. We'll start by subtracting the 2 to the other side. So we have negative x over 4 is greater than negative 2. Now, we'll go ahead and divide both sides by a negative, negative 1, but that's going to flip the inequality. So we're going to have positive x over 4 is less than positive 2. And finally, I'm going to multiply both sides by 4 to solve for x. Since we're multiplying by a positive, the inequality stays the same direction. So I have x is less than 8. So now I have to figure out where these two intersect. So what do they have in common? So the only parts they have in common are x values less than 8. So in interval notation, we're going to say all x values from negative infinity to 8, not including 8, so we'll use open parentheses around 8.